Welcome to design of steel structure. In our last video lecture, we have discussed about the design steps which are involved to select this particular section to carry a particular amount of load, and also we have found that is spacing. What should be the spacing of this section, and also we have discussed about the steps like how to design this lacing bar. Okay, this lacing bar. Okay, now the one important part is left, that is how can we connect this channel section or the section, okay, by this lacing. Because if we can't connect this two channel section, okay, these two unit will not act as a single unit. That means our purpose of the built up column will not be served. So it will be only served when we can make proper connection. Okay, now if we don't make any connection, what will happen? If there is some lateral force, like lateral force are due to the wind force and also the earthquake force, so what will happen? So these two section will be separated. Okay, so it will so the overall stability will be disturbed, so it will not act as a single unit. Okay, so we have to make proper connection. So that's why these lateral force are considered. Okay, this Vt by n in case of designing this lacing bar. Actually, if it is a properly compression member, this column, then theoretically there should not be any lateral force. But in actual site, what happens? There are some lateral force which acts on a structure like wind force and earthquake force. So we should consider some lateral force in the design. Okay, otherwise if you don't consider in the design, okay, then your structure what you will design, that will not serve the purpose in case of actual uh, uh, demand. So today we will see how to connect and how to connect this lacing or lacing with the sections. Okay, so for that this force diagram is important. Okay, and also you see there is two different type of connection, like these two lacing bar is connected on a single bolt, and here one lacing bar is connected on a single bolt and another is on the another bolt. Okay, so depending on this type of connection, the force on the bolts depend. Okay, because in case of connection design, we have to design the bolts so that the bolt will be sufficient to carry that load which are coming through this lacing bar. Okay, so the bolt should be sufficient. Now what are the steps? Okay, so you can see here in point number 17. Okay, if you read this point number 17, you see in case of riveted or bolted construction, the strength of rivet or bolt is calculated. Okay, because we have to know the strength of the bolt, otherwise we cannot design how many number of bolts will be required. Okay, so strength of bolt should be required, and should be more than the load coming from the over the rivets. So it is very clear. In case of two lacing bar are connected at the same point, okay, as was in the figure number 1, okay, the load over the rivet or bolt will be 2 into Vt by n cot theta. You know all these parameters. Whereas for lacing flats connected at the different points, the load on the rivets or bolt will be Vt by n cosec theta. Okay, now this will be sufficient to design this connection, that means the bolt. Okay, now another important thing you should know, suppose in case of this designing, there are some situation where you have to overlap this lacing bar, then what should be the criteria and what should be the point that should be kept in your mind? So overlap for lacing bar should not be less than 4 times the thickness of the bar or the member, whichever is less. So whenever there will be overlapping, so you have to keep this point in your mind. Okay, now to number point number 18, to check the distortion of the column section at the column ends, tie plates are like battens. So this is tie plate. I will show you the picture. So are provided at the ends of the lacing system. These should be able to resist the forces on which the lacing flat is subjected. Okay, the tie plate is designed as a batten plate. Now, so at the end of the lacing system, you have to provide this batten like this figure. Okay, so no any intermediate batten, because in case you are designing the batten column or built up column by batten system, you have to provide the end batten, okay, on the two ends, and in between this end batten you have to provide some intermediate battens. Okay, so in that case you will provide this, and in some particular cases designer have to decide whether it is required or not. Okay, so now what are the parameters involved in this design of end batten or tie? Okay, so important points that is I will mention, that is we need this depth. See here in this figure we need this depth, this is d dash, and this is the width. Okay, you can find this width. Okay, so what would be d dash? D dash depth is equal to d dash s dash plus 2 into cyy. So spacing between the channels or the sections. Okay, and on the left cyy, on the right cyy. That means s dash plus 2 cyy. And overall depth of the end batten is equal to d dash plus 2 into edge distance. So for if you select a particular diameter of the bolt, you can find the edge distance. So you have to just add this edge distance, 2 into edge distance, to find the overall depth of the end batten. Okay, so these are the formulas to find out the intermediate battens. So this is not our case, but you should know this case if you want to design the batten column or built up column by batten system. Okay, now another thing is important, you should select this thickness. We have what will be the thickness of this batten. So that for that thickness is mentioned here. The thickness T of the batten should not be less than 1 by 50 the distance between the innermost connecting lines of the rivet. Okay, so what will be the innermost connecting lines of the rivets? Okay, so that will be, now see this figure, so where it is S dash, okay, and where this board is connected here. So from this point to this point it is uh, G. Okay, it is available in the steel table. So here also it is G. Okay, so the distance between this bolt to this bolt, okay, S plus 2G. Okay, so here it is mentioned that the thickness T of the batten should not be less than 1 by 50 of the distance between the innermost connecting lines. So innermost connecting lines are S dash plus 2G. So this is the distance. So 1 by 50 of this. So it should not be less than this. So at least it should be more than this value, 1 by 50 of the S dash plus 2G. Okay. So uh, then another point you should know, this is not required for the lacing design, but you should know if you want to design the batten system. So in case of lacing design, we have calculated this slenderness ratio of the overall column by increasing the 5% value. Okay, so in case of lacing system, the overall slenderness ratio is equal to 1.05 times of the slenderness ratio. Okay, now in case of batten system you have to increase by 10% this ratio, effective slenderness ratio, which is increased by 10% to the account for the shear deformation in case of batten column. Okay, so this thing you can read it from the book, and also you have to ensure this point number one for batten system. Okay, and also another point that is mentioned here, you have to ensure these points, you have to study these points for the batten column. Okay, now I want to tell you one more thing, that is in point number 16. Suppose I have not discussed this point number 16. So tensile strength of the flat is calculated. Okay, before these steps, it is saying that tensile strength of the flat, that is lacing, should be calculated, and it should be more than the force of the lacing flat. Okay, so why it is required? Because as you see, this column is a compression member. Okay, so there is no point that it will be subjected to any tension force, because compression is coming. You see this on these flats, this compression is coming. So why should we design this lacing bar, or why should we check the tensile strength? So as I was saying, suppose these lateral forces are coming from the lateral side, then it may happen that this lacing bar will be subjected to tension. Okay, if you can visualize this, you will understand. So in case of lateral system, like lateral force, that is earthquake or this wind force, this lacing bar may be subjected to the tensile force. So if the tensile strength of this lacing bar is not sufficient, what will happen? This will break. Okay, there will be rupture or cross section yielding. Okay, so in that case, this connection will be broken. Okay, so you have to ensure that in that accidental case, it should not be broken by this tensile force which may come into the picture. Okay, okay, so in the next video lecture we'll solve a particular question, and we will design the total lacing design. Okay, so this is going to be lengthy question, but if you understand it, it will be very easy to solve.